kids, today we're going to talk about section 1.5, technology, calculators, and computers. And for that, I'm going to be using my TI-84 Plus, which will work similar to like a TI-83 and most other TI-84 calculators. If you have any TI calculator, it'll work pretty similar to this. If you have a different calculator, I can walk through with you in class on how to do it. If I don't know how to do it, I'll help you look it up and we'll figure it out together. But most kids tend to use these calculators, so that's why I've chosen to do these ones. Okay, so example 1. It says, how many real roots does this function have? And I guess just starting with the terminology, real roots is just asking us where it crosses the x-axis. So we're going to open up our calculator, and it might be hard to see if this is kind of small. Let's see if I can make it bigger. No. Alright, I guess that's how it's going to have to be. So we go to this y equals button, and we type in this function. So this button, x, t, theta, n, that's how we get our x. And then caret 9 minus 20, go back to that x button, plus 1, and then we're going to hit graph. Now in this graph, we have to wait for a little bit. It's really hard to see where these values are. So what we're going to first do, just so we can see it, to me it looks like it's about 1, 2, so I'm going to go about 3 in the negative direction and 3 in the positive direction. And then we're missing some stuff up top, so maybe I'll try 15. And it's really just kind of a guess and check. So that's my minimum x value, maximum x value. Just leave the scale at 1. And then this one I'm going to go from negative 15 on my y to positive 15 on my y. Once again, leave the other stuff how it is. Go back to graph. Hopefully this is a little bit better to see. Alright, so I think the x is good, but we're still missing the top and the bottom. But for this specific question, we only care about where it's crossing the x-axis. So I think we're fine. So we're going to just like keep it like this. If you wanted to, we could go down here, maybe try 25, so negative 25 to positive 25. Whoops. There we go. And now we can see the whole thing. Now, it might be tempting to use the cursor, but we're going to find it exact. So we're going to go to this calc, which I have to go second, hit this button, and we're trying to find a 0. So you can either just hit the number 2, or you can go to 2 and hit enter. And what it's going to ask for is a left bound. So I'm going to find the leftmost. So I just click somewhere to the left of the root I'm trying to find. And then it says right bound, so I just want to make sure that cursor is to the right. And then it wants me to guess. Thanks for a minute. And then we get negative 1.46 on that one. Okay. So we have negative 1.46. Okay, and we'll go through that same process for the one in the middle. So I'm going to hit 2 this time. It wants a left bound. Okay, so I'm to the left of the one that's crossing. That looks like it's crossing at 0, but we'll see if it really is. And we click to the right, and now we guess. Thanks for a minute, and we see that it wasn't 0, it was 0.05. And one more time. Hit a 2 for 0. Okay, we want to make sure we're to the left of where it crosses. Hit enter. Make sure we're to the right of where it crosses. Even though I went off the screen, that's still okay. And see how this guess, like I'm pretty far off, but it just needs to know the closest root that I'm looking at. and it's positive 1.45. 1.45. Okay, so it crosses 3 times. Those are the 3 roots. That's all you have to do. Okay, let's move on to example 2. This says, does cosine x equals tan x have a solution? And then it wants us to describe the set of all solutions. So what we're going to do, if we ever have an equation that we're not sure how to solve algebraically, what we can do is we can hit the y equals button and graph each side individually. So we can say cosine x, and then go down here and do tan x, and then graph it. And wherever they cross, that's going to be the solutions to the problem. Now I still have that window from the last problem, which is not the best window. It's good practice to change from -10 to 10 on the x, and then -10 to 10 on the y when you start a new problem, and then adjust your window accordingly. Okay, so we see that it's crossing like above and below, and then it's periodic, so it's going to do that like forever. So I'm just going to look at these 2 places that it crosses. So I'm actually going to change my x window to about 0. It's kind of hard to see. Maybe let's just try 0 to 5. And then I'm going to do like -2 to 2 on the y. Once again, just play around with it. You'll get kind of a feel for what's important and what values you need to see. So we see it's definitely crossing here, and it's definitely crossing here. Then when it goes back up here, it'll cross at the same place, just shifted 1 period over. So we're just going to do like a 2 pi k thing like we did in one of the previous problems, and I'll explain that when we get to it. This process is similar to what we did on example 1. We go second calc, but this time we don't want a 0. We want an intersection, so we go to 5 this time. And it just does it wants you to choose the first curve, second curve. So if you only have 2 things graphed, then wait, I don't even know where the cursor is. There it is. Okay, so I actually want to pick this left one. There we go. Okay, so it says choose the first function, choose the second one. So it says choose first curve, second curve, and then you have to guess where they intersect so it knows where you're looking. And this is 0.666. Okay, do the same thing. Second calc, intersection's 5. And so if you only have 2 things graphed, you can just go enter, enter, because there's only 2 curves to choose from. Now I'm going to the right. Just keep going to the right, okay? Guessing where they cross. And that's 2.48. Wait, was it point? No, 2.48? I gotta look at that again. 2.48, yeah. Okay, those are the 2 places it crosses, but if we pull back just a little bit, so if I maybe go to 10, we see that it's going to cross twice during every period. And it's going to be in the same place. So from here to here is 2 pi. From here to here is 2 pi because the period of cosine is 2 pi. So what we're going to do, we're going to modify these answers that we have. We're going to say x is approximately 0.66, but that's going to occur every 2 pi. And then we just say k is contained on the set of all integers. So we can plug in a 0, a 1, we can plug in -1, all that stuff. And then we do something similar to show all the possible solutions. And that would be the same k. Okay, that's everything for that one. Let's move on to example 3. Okay, this one says plot the function f of x and describe its asymptotes. Okay. So when we have functions like this, we often have two asymptotes. But since this is like a graphing section, we don't even have to really think about it before. We can just clear these out, maybe even change our window. -10 to 10. All right. Now I'm just going to plug this in. It's good practice to just put the top of a fraction in a parenthesis, then hit divide, and then do the bottom. Like that. So we graph it. Alright, there's definitely a vertical and a horizontal. So we're just going to kind of zoom in to where we think it is. Looks like it's 1, 2, 3 would be my guess. So I'm going to go from like 0 to 5 again, and then maybe 0 to -7. So 0, 5, 0. Whoops, this one, you gotta do the minimum first. So -7, and the max is 0 on that one. That's definitely not what I wanted. Okay. Let's put this at maybe 5. My y max was wrong. Okay. Okay, that's kind of a tight window, but I think we'll be okay. Now, what I'm going to do, I'm going to just test an asymptote. So I'm going to go here. I'm going to test the horizontal. So to me, it looks like it's like maybe -5. So I'm just going to do y equals -5, graph that, and see if that looks good. Now, it's definitely the wrong asymptote because it's crossing this. So I'm going to move it up probably 2 and then look at it. Alright, that looks pretty good to me. We're going to zoom out and make sure that looks good, but let's worry about the vertical. 1, 2. Okay. Now, an easy way to find the vertical is what would division by 0 be on this. And so if we plug in a +2, there's going to be division by 0 in the problem. So I feel pretty confident saying that that one's 2. Now there is a way to do it without graphing to figure out the horizontal asymptote, but this is a graphing problem, so let's not even talk about that. So I'm going to change my window. I'm going to zoom out maybe just a little bit on the x. Maybe we'll do that. And then the minimum, -8 to 8. Okay, let's try that. And we're going to see if that asymptote, that horizontal asymptote still looks good. It does. So I feel pretty confident that we have a horizontal equals to HA. Horizontal was y equals -3, and vertical asymptote was x equals 2. I guess, let me pull that up so we can just see that. So x equals 2 is right here, and then we have our horizontal asymptote right there. Okay, so this is example 4. How does f of n equal 1 plus 1 over n raised to the n behave for large whole number values of n? Does f of n tend to infinity as n gets larger? Okay, so we're just describing like what happens as this goes to the right really far. So large numbers of n. So once again, we can graph it. We're going to go to y equals, clear this out, and it's going to show up as an x, but it's going to give us the same information. Okay. I'm going to change my window before I graph it. So I'm going back to that default window. Now we see this part in the negative. We don't really care about that for what it's asking because it wants to know for large values of x, which means positive, like as it goes to positive infinity, what is it doing? Okay, so in this case, we want to see if there's an asymptote on top because it's definitely going up. We want to see if it like completely flattens out or if it gets closer and closer to an asymptote, or if it just keeps going to infinity. So I'm going to change my window. So as far as x values go, we definitely don't care about anything negative. And let's go to like 50. Or maybe even like, let's try like 1,000. Because we want to see something really big, like what it's doing when it gets really big. And then, I don't know, let's try 0 to 4. Because it didn't really go that high. Okay, let's look at this. Alright, so it goes there. It definitely looks like it's flattening out. So we want to figure out what value that is. So I think this is a 3 up here. 1, 2, 3. We go back to y equals, try 3, and graph it. Okay, I think it's lower than 3, but it's higher than 2. It's like maybe 2.75 is what I would try. Taking a while. Okay, so that's really close. Now I'm gonna go zoom in. I'm gonna say like for the y values, I'm gonna make the minimum 2, the maximum 2.8 or something like that. Let's actually even do 2.5. Let's look at that. So we can see more detail. We can see it's still climbing. Alright, and that's a pretty good asymptote. My guess is, with this one though, it's going to be like 2.7. It's going to be Euler's constant, or Euler's number, whatever it's called. Just the letter E. That would be my guess. And if you read through this section, there's actually a proof of this in section 7.1 that this does converge to E. We won't do that right now.